In this lesson, we're going to cover basic hardware configuration in step 7. I'm going to open an existing project. This project has a Simatic S7-300 station. If I expand this station out, you will see that it has a 315F-2 PN/DP CPU. When I do select the station, you then have access to the hardware configuration editor. I will open up the hardware configuration editor. The top portion of the hardware configuration editor shows you your local PLC rack, as well as any networks that are configured within the system. The bottom portion of this editor will show you more detailed information. Say, for example, when you have the local PLC rack selected, then you see all the information for the local PLC down below. Coming off the MPI DP port, in this project it's configured for Profibus DP, so I do have a single ET200S node that is attached via Profibus. On the PN-IO port, I've got a Profinet network, and I also have an ET200S remote IO drop configured in this project. On the right-hand side of the screen, you have the hardware catalog. So if I wanted to add in an additional Profibus component, I could select the Profibus DP category and then drill into a particular category like ET200S. And I could select one of the interface modules or head modules, drag that in, and attach that to the Profibus DP wire. So I'm just going to get rid of that node. I'll minimize the Profibus DP category, and we'll go to Profinet IO. And I will select the IO folder, and I will also select ET200S. And in here, I could select this particular head module. When you do select a component in the hardware configuration editor, you do get details down below. So for this one, I could just drag and drop this onto the Profinet network, and then that would be assigned to the Profinet network. So I will delete that one as well. Minimize the Profinet IO. I will expand out the Simatic 300 category. If I wanted to add an additional rack, I could select the rack category and bring in a rail. So I'll just delete that because we're not going to be using that. If I go up to the CPU folder, I've got all the different categories of CPUs that could be selected. Say, for example, I wanted to bring in a 315F-2 PN/DP. I could select the particular part number and the firmware version, and then be able to bring that into the project. There is a folder called SM-300. This is for your signal modules. If I wanted to add in an analog module, I could pick the AI-300 folder, and I will just grab this module here and drag that in and put that in slot number 5. You do have the option to be able to right-click on a component and select Replace Object. I'll select Simatic 300, and then it gives me a list of suitable replacement modules. Your hardware catalog is provided at the time of installation. Should you need to update that catalog with additional components, we can update the catalog with Siemens components. So I can go up to the Options menu, select Install Hardware Updates. If you do have an internet connection, you can download the possible updates and then select which ones you want to install. Or if you've already downloaded the updates from the Siemens support site, you can select Copy from Disk and then pick your components that you would want and then go through the installation process, and then your catalog would be updated. If you are working with remote I/O, such as Profibus and Profinet, if you need to add in additional components from other manufacturers, you could select the Options menu and pick Install GSD file. Then you would be able to browse to a location that has your files, select which component you would want to install, and then select the Install button, and that would update your catalog. To configure the individual modules or objects within the hardware configuration editor, for example, for the CPU, you can just double-click on the CPU, and that would bring up the properties for the CPU. There are a variety of tabs that are available with various properties that can be configured. So I'll just select the cycle and clock memory. As an example, on this tab, you can see the scan cycle monitoring time. You can see the size of your actual process image input and output areas. So any I/O that doesn't fit within this boundary would be considered peripheral I/O. There's a retentive memory tab, so you can configure various retentive memory areas. Go over to the cyclic interrupts. Here, these would be organization blocks that are code blocks that execute on a cyclic basis. So OB35 will execute every 100 milliseconds. So I'll just cancel the property configuration. I'll select the MPI/DP port. This port is a dual purpose port, so it can be configured either as MPI or Profibus. Currently it is configured as Profibus, and the node address for the CPU is 2. If I select the Properties button, I could configure the network properties in terms of the network settings. I'll select the PN-IO port. Select the Properties button here, and again you can see the IP address that's configured for the CPU and which network it is attached to. I will open up the DI8, DO8 module, so digital input, digital output card. Depending on the module that you have selected, you may have multiple tabs available up here for configuration. This is a pretty basic module, so from a configuration standpoint, I can select the Addresses tab and just configure the starting address for the inputs and the starting address for the outputs. This determines where the I/O is going to fall within the process image input table and the process image output table. So this card uses 1 byte because it has 8 inputs, and it also uses another byte for the outputs because it has 8 outputs. I do have a 2-channel analog input card in this project. So if I double click on this, I can configure, again, the addresses. Now this card has an additional tab. If I look at the Addresses tab, it's a starting byte address of 272. If I select the Inputs tab, this is where I can configure the actual properties. For example, the measuring type. I can deactivate the channel, or I can enable it, and maybe we'll do voltage. Can select my measuring range. Once I'm satisfied with my configuration, I can select Save, and that will save my hardware configuration. There is an additional step. There's a button that is called Save and Compile. So when you press the Save and Compile button, that will actually create the system data blocks, which would be your hardware configuration that would be downloaded into the controller. When you hit Save and Compile, the system data folder will contain your compiled hardware configuration. In this lesson, we covered basic hardware configuration in Step 7.